Live from the office of Claudine Morales, this is AWS Howdy Partner!
Hello, everybody. Claudine Morales here. We're live from my office. Welcome to another episode of Howdy Partner. We have a great episode brewing for you today. I am joined today by one of my colleagues, Gregor Richardson, who is co-hosting his first ever episode. Gregor, take it away.
Hello, world. Hi, everybody.
Say hello.
So I am a partner solutions architect here at AWS. And part of what I do is find out all of the cool and interesting things that our partners are working on. And I have the opportunity to work with Claudine and a bunch of other fantastic folks. And I have an opportunity to work with some fantastic partners, including Rob, who's here with us today from Dynatrace.
That's right. Hi, guys. Yeah, very happy to be here. I'm Rob from Dynatrace. I'm a technical partner manager, and I work really hands-on with technologies and work actually every week with AWS. And so today, yeah, excited to be part of Howdy Partner.
Thanks for joining us, Rob. And we actually forgot to tell everyone what Howdy Partner does. Gregor, what do we do here?
So on Howdy Partner, what we do is we like to highlight some of the interesting things that our partners work on. And at AWS, we have the opportunity for a wide range of different partnerships all through the platform. That's the gist of it here. But Claudine, like what extra flavor do you want to add to that?
No, I think you covered it well. Yeah, we're here to highlight really cool partner solutions that enhance our customers' use of AWS. And Rob is here to talk a little bit about Dynatrace and the cool things that they're doing over there. Here at Howdy Partner, we've talked so much about modern application development. It's always a good time to talk modern app development, and this is what we're going to be talking about today. And I think particularly we're going to drill into containers and some of the challenges of using containers in your workloads and how Rob and Dynatrace can help with those challenges. Gregor, you prepared something for us today.
Sure. Yeah. Well, I'm just going to casually talk you all through the world of containers, because what we're really going to focus on is Kubernetes, and then getting observability into your whole stack once it's deployed. But there's a lot of layered stuff there, and so just to make sure we're all on the same page with some of the basics, a brief intro to containers. The concept of containers, it's been around for a number of years now. And effectively, it's an approach to package all of your runtime and your dependencies and your code into a single artifact and put it as a single thing into your build process. And that approach, it's helped simplify how applications, modular applications are packaged and how they're deployed. So it's easy to imagine, but in the world of application development, there's a lot of different ways to manage your code environments, and it's and a lot of moving pieces owned by a lot of different parts of a typical dev team. But using containers, it ensures that your local environment is going to be the same as in production. And as somebody who's dealt with dependency versioning issues and runtime problems and binary incompatibilities, containers are a very refreshing, consistent experience. So containers, they're also very similar to the general stance, to the general virtualization concept, in that they provide a way to isolate your resources. And one of the functional differences between containers and traditional virtualization is that virtualization, it builds its construct from the hardware level, whereas with containers, it piggybacks on the existing OS kernel, and that allows it to be smaller and more efficient, which is why it's a part of these dev workflows. I want to keep the terminology as simple as possible, but one thing to talk about and to mention. It's hard to get into containers without bringing up Docker and the Docker engine, which is the most common standard, which has been around since about 2013, and it runs natively just about everywhere on Linux, on Windows and Mac and data centers, and obviously in cloud infrastructure. And it's not the only standard, but it is certainly the leading one. And so containers are great, and they have revolutionized the way that apps are developed for a lot of different companies. And it's a big part of many people's workflow. But once things are actually in a container, and once you're managing that container, it's fine. But what happens when you have multiple containers? It can very easily, very quickly get to the point where the management of containers, and which is referred to as orchestration, requires additional tools. And there are lots of orchestration tools, or there are at least a few orchestration tools out there, but the most widely used is Kubernetes. And Claudine, I'm going to turn to you to ask what we need to know about Kubernetes.
Yeah, I'm just going to do a very high level talk on Kubernetes, really fundamental concepts, and then this is really Rob's show, so I'm gonna have him do a lot of the talking here after I'm done. So I'm not going to try to take up a lot of time here, but in simple textbook terms, Kubernetes is a container orchestration platform. It helps you with automating the deployment and management of your container applications. Why do you want to use something like Kubernetes? So in the modern age, in today's world, we see a lot of modern applications getting created, microservice architectures. It's really not uncommon for us to see companies deploy thousands and thousands of container instances every day. And if you find yourself at that scale, I think you're going to learn very quickly that the deployment, the management, and the scaling of these thousands of container instances could present a huge challenge. And this is where Kubernetes comes in. It can help you automate tasks like load balancing requests across multiple container instances. It can help you send load to new available resources, to monitor and control how much resource an application consumes, moving an application from one host to another if there's a shortage of resources in a host. It also helps you do blue-green and canary deployments. It helps you do rollbacks more easily if there are issues with a new release. I think Rob is going to touch a little bit more into these deployment strategies a little bit later. But, for those who are not familiar with these concepts, blue-green deployments, basically you have two identical production environments stood up at once. You send all the traffic to one of them. That's your blue environment. The other environment, the green one, it's a clone. It sits there. It's idle. You use the green environment to test a new version of your app. So you might send, very little traffic there for testing. And if all goes well, you route traffic from blue to green. And so green now becomes your new prod. If there's any issue with green, you route the traffic back to blue. Canary deployments, similar concept, but they take a more incremental approach. Say you have a new version of the app. You deploy the new code first to only a small part of your prod environment, then you route some traffic to that. If there are no issues, you gradually roll that new code out to the rest of your production environment. So you're really rolling out your latest app version in phases. These deployment strategies are both beneficial for reducing impact. Like if there is a bug in your new application version, you don't end up impacting your entire production environment all at once. But they can also be challenging to pull off if you're doing things manually. And this is why you use a system like Kubernetes, which can help you automate your deployment, your load distribution, things like that. There's a lot to say about Kubernetes, and Kubernetes.io is a great, I think I'm going to start sharing my screen here as well, if you guys don't mind. Yeah, so Kubernetes.io, great resource for learning everything Kubernetes. One of the concepts I'd like to quickly touch on today, though, is the pod. What is a pod? With Kubernetes, you don't actually manage containers directly. What it does is it groups together containers into this unit called a pod. The pod is the smallest deployable unit in the world of Kubernetes. And the purpose of the pod is to run one instance of your application. It's very common to have one single container in a pod, but you can have multiple containers in a pod. Containers in a pod, they share the same network and storage resources. So you can have Kubernetes deploy replicas of your pod in order to scale if the load in that one pod becomes too much. With Kubernetes, each one of your pods gets their own IP address. Here's the thing though, Kubernetes pods are essentially mortal. They only live once. So once a deployment terminates a pod or a replica, it's dead. You cannot make it come back to life. If you spin up a new pod in its place to perform the same function, the new pod is going to have a different IP address. So the issue here is this: what if an application depends on that one pod that you killed, and it only knows of the dead pod's IP address? How is the application supposed to find out about the new pod's IP address so that it can call it at the right place? The solution is the use of what's called a service. And I thought I would touch on this because I know Rob is going to be dropping this term a lot in his demo later on. And I want to make sure that you have some context on what a service is and why you might need one. So a service is an object that enables network access to a set of pods. When you create a service, you define what can access it and where it should be routing requests, like which group of pods it should be sending requests to. In the service YAML file, you will specify the service type, essentially what can access it. It can be made available externally through a load balancer, and I think Rob's demo app for later has a service that's available through an LB. You can also make it available outside the cluster or even only from within its own cluster. So in your service YAML file, you'll also specify what's called a selector. And this is the label for the pod that you want all the requests to be routed to. Now, of course, when creating a deployment, as you see here on the screen, if you're creating a deployment to create your pods, you also attach labels to your pods. I have two very simple YAML files side by side here to show that the selector attached to your service matches the one that's attached to the deployment, which creates a pod. So this service knows to send requests to the pods with that label. So now you see, instead of calling actual IP addresses and having to keep track of new IP addresses every time a new deployment gets created, you're using a service that is defined to route requests to a specific group of pods. Your system becomes more dynamic. So that's a lot of talking so far, and I really should stop. But before I stop, I need to mention that, of course, AWS offers a fully managed Kubernetes service, and Amazon Elastic Kubernetes. I'm going to stop sharing my screen because I don't have to. But yeah, EKS, some of the great things about EKS is, of course, you get high availability. AWS runs your EKS or your Kubernetes infrastructure across multiple data centers. We call those data centers availability zones. It also automatically gets rid of unhealthy nodes and replaces them. You don't have to worry about upgrades and patches for your nodes. It's a fully managed service, so we take care of that for you. It is, of course, secure. Security is job zero here at AWS. So we are dead serious about security upgrades and patches. And very importantly, it gives you the option of running your EKS clusters using AWS Fargate. And what is AWS Fargate? It is serverless compute for containers. So you don't even have to worry about managing and provisioning your own servers. You should visit the EKS page for more information. Hopefully, I've covered the benefits of using Kubernetes for your modern apps as well as EKS. But as in all great things, it all comes with its own set of challenges. And this is why we're here today. Rob is going to take us through some of the challenges of, using Kubernetes or containers as a whole, and what Dynatrace can do to help us with those challenges. I think before I ask you the first question, Rob, I would really like for our viewers to learn more about Dynatrace and what do you guys do as a company? What do you offer?
Sure. Yeah. No, I mean, one, I think you guys shared a great job about Kubernetes, first of all. So yeah, and I'll have a couple comments to add about all of that. But yeah, so Dynatrace is a partner with AWS. We're a publicly traded company. We're a global firm, and we're best known for as sort of an advanced observability tool that kind of works with both the on-premise infrastructure as well as all the cloud providers. So we're going to see a lot of this today, and I'm going to walk through kind of our architecture. But essentially, we're using a data collection with also being able to trace the service to service process calls to create a topology of everything that's going on in a dynamic way. And then we feed that into an AI engine that also helps us get to root causes of problems and automatically baselining the behavior of, the end users as well as the applications and then the underlying services, whether it's physical or cloud resources. So, we've worked with a lot of very large enterprise customers. So some of the big names you guys have heard of. We've got a lot of great case studies that we can share on our website with companies like Carnival Cruises, for example, like a lot of work with them, major airline companies, lots of major banks. So when performance, for a Black Friday event is hitting your website, being able to understand the behavior of the app, what users are experiencing good response time or not, and then where does that trickle back into the infrastructure? And that's kind of what we're going to cover today. So as we get into containers and more complexity and more things talking to each other and things coming up and down and being in a more dynamic way, you really need some technology to help you with that. So you may know your 3-tiered app inside and out. You do deployments every 6 months, but the new world of breaking everything into smaller pieces, having everything come up and down, both deployment-wise and in doing the blue-green deployments, the canary deployments that Claudine was mentioning, you really need some solutions to help you with that because it's just humanly impossible to do it in the old way. So I think that's where Dynatrace is there to do that. And hopefully we're going to showcase today some of those examples and you can get to see it in action. Yeah.
Fantastic. Yeah. And for those viewers who are just joining us today, this is Howdy Partner, and we're here with one of our APN partners, Dynatrace, to talk about the challenges of modern app development and how Dynatrace can help us there. What do you think? So I was just talking about Kubernetes and the high-level talk that I gave. Rob, what do you think are the good and bad of Kubernetes?
Well, I mean, I can start even back with what Gregor was talking about. So, I mean, the applications have been migrating from, an application piece of code where you compile something, it could be your Java app and you run it in an app server. All of that code, was gone into virtualized servers like VMware kind of solutions, and now it's moving into this containerized kind of format. So the containerization is, a way to make it very portable. So I think, Greg, I don't know if you mentioned that one, but it's the portability of that code. So whether I run it on my desktop with Docker natively or a Docker Compose, or I push it up into Fargate as a standalone instance, or I deploy it into a Kubernetes, container management platform, that's the portability you get. And you can move it across different operating systems. So there's many. The Kubernetes is as a standard that's kind of out there and really growing in popularity. And then EKS, as Claudine said, is really the managed offering of that. So instead of you having to manage the actual Kubernetes, everything about it, patching, things like that, high availability, that is where you get Kubernetes on EKS on top of that. So what we're going to see with Dynatrace is Dynatrace has an agent technology that runs on top of Kubernetes. So as your pods that she mentioned come up and down, we don't have to put our agent in the pod. We have the ability to what's called sidecar injection. So we have our agent attach itself dynamically to the running pod as it spins up, and that injects itself and is instrumenting the code and all the communication between pod to pod. And that's what we're going to see. So that's really one way where we see what the application health is, what the different communications are by, having that ability to connect the distributed calls through that technology. And
well,
the reason we do that, we'll see that. I'm sorry, go ahead. Yeah, got excited there. Yeah.
Yeah, well, I'd love to see a little bit more of your tool. Do you want to kind of take us through your demo
sure.
here?
Yeah, let me show a couple things. Absolutely. So let me share my main screen, and let me I'll do one thing first, because I think you asked about Dynatrace. So let me just get a little more details about Dynatrace first, and this is really what we want to talk about. So with the problem with Kubernetes, it gives you the platform for spinning up your pods, everything you mentioned around different services that are able to kind of front end that particular pod. We didn't talk about service mesh, which is a whole nother kind of topic around managing the network within Kubernetes. But what Kubernetes itself doesn't give you anything but these types of things to see what your application's doing. So your application would have logs, presumably. Kubernetes has logs. Kubernetes also has metrics around what it's doing, and that often you hear is exposed and made available things like through Prometheus, which is an open source kind of data collection tool. And then these traces are also kind of made available also through things that have to be done in your code itself to help instrument what is happening as your code is making calls. But what we want to do with Dynatrace is kind of enrich that, so we can get some great information from metrics, logs, and traces. And you hear, that is you often just, that's all I need. I have Prometheus, I can see the data, or I can see what's happening with the app. But what we feel is missing, and this is what we're going to show with Dynatrace, is that it's the dependency between your applications automatically seeing what's happening there. What is happening between this service and that service without you having to instrument your code? And then also, like, what's happening, how does the services that are running Kubernetes match back to the end user and what they're doing in their browser or mobile app? And then as things are coming up and down, that's what we're going to see with Dynatrace is how do we manage this in a more complex environment? So if I have hundreds or thousands of services across multiple namespaces is the way of partitioning things in Kubernetes, how do I automatically discover and see these things? How do I also, if some of my services are running outside of Kubernetes and then we're slowly migrating to Kubernetes, some stuff's on-prem, some stuff's in Kubernetes, trying to piece this all together, and then the challenge of automate, all the analysis, like how do I automate collecting and analyze all these things? So Dynatrace is trying to solve, those missing pieces and then really the automated analysis. And the way we do that, and I'm going to jump right into showing you, is so Dynatrace in its kind of core technology is this thing's on the bottom here. We have an agent technology called One Agent, which is something that can run on a host outside of Kubernetes, but also run within Kubernetes as this operator model, which I'll show and describe in a second. But it's all about capturing the code, the traces, the metrics, the logs, the end user behavior, all within one agent. So what makes Dynatrace unique is that this one agent, and that's a great name, can actually automatically capture and configure all these things. And what's happening is it's building a smartscape. With the terminology we use is smartscape, which is all this dependency mapping feeds into an automatic dynamic view of what's happening in your infrastructure. I think once you see it, you'll really understand the power of what the smartscape is. But what on top of this data, now that we have the topology and all the metrics and logs and events, we feed it into an AI engine for doing things like, hey, what does normal of my application mean across hundreds of different metrics, response times, throughput, errors, what is the user behavior, what are the exception messages, what does normal mean, and feed that into an AI engine, which we'll see as well in the demo of what that's all about. And it's not just limited to our one agent data. All data can be fed in from other sources. So with AWS, we can bring in data from CloudWatch. So if you don't have a one agent running on something, say, show that in a second too. We have like multiple services. That same data can come in, be baselined by Davis, and also kind of feed into where there are problems in your app. So this is sort of our core technology as our platform. And then what we do specifically with AWS is the core compute resources that you see here on the left are where an agent kind of ties directly into that to pull in what we call full stack deep metrics, and that's what I'm going to show you in a second. But then if it is CloudWatch, all the services that are exposed, we bring in that data through the CloudWatch API to feed into Dynatrace itself. So that's kind of a quickie overview of the Dynatrace, and let me just show you now what it looks like and sort of the demo app that we have prepared today. So what I'm going to show you guys is we built an application to really something simple. And I'll kind of show how we're going to kind of walk through a couple things today. Is I wanted to build an application to kind of show a little bit of complexity of, your front end app may call another service, that service calls another service, and so on. And if we have problems, how do we know where that is? How can we detect that? And so without a tool like a Dynatrace, we may have to look at each individual app. If these apps in turn are owned by different groups, then different people have to get involved to kind of triage this thing. And so what we're really hoping to show is in Dynatrace, this is what we're going to see, is that as Dynatrace analyzes the behavior of the app, it's putting together in the case of a problem, piecing together automatically that topology of your environment and letting you see that, hey, I have impacted users, I have impacted services, and then by knowing, and it's so the heart of it, the engine is an AI engine that does the cause and effect. So we call it a causation engine. It's not a correlation engine. We're not looking at logs and timestamps. We're actually looking at behaviors built into a huge database that's built into Dynatrace to look for cause and effects to come up with what it feels is the root cause of the impact. So it will automatically tell you, hey, the failure rate on this underlying service was the root cause that bubbled up to impact all these other users. Sometimes it could be many things, not just failure rates. It could be resource utilization, memory problems, threading problems, CPU problems, and it helps you prioritize it. So you may have a bunch of errors, but do I impact users? Do I impact other people? And if I don't, then I don't have to prioritize that as high. So that's what I want to show you today. And with Kubernetes in particular, it's very dynamic. So I'm hoping to kind of demo that today for you guys to see what it means to run something in Kubernetes for one. And this sample app that I have is all I have. It's in GitHub. It's all public. You can read it, check it out, check all my scripts out, etc. So what I have is a very simple web application, and this is what I'm going to demo. So in case I have a Kubernetes environment in EKS. Actually, maybe I'll show you that real quick. So I know I'm going to bounce. Sorry. So in my environment here, I have, and we'll just jump right to my EKS environment just to show you what it looks like. So this is the AWS. If you're assuming most of you are, but this is the AWS console. And if we look for different resources, I've created an EKS cluster. And so if you don't have one, you can create the cluster right from the web UI and follow the prompts. But in my case, I just have Kubernetes. So this is the managed aspect of it. So when I make my cluster, it's going to be building a number of the compute resources for my pool. It's going to be my whole managed environment, and it's living here now in as a service from an AWS. So when I do things, and so this is where Claudine was mentioning a bunch of pods and things like that. I'm just going to show you my environment. So I'm now logged into a Linux machine where I can see my environment. So Kubernetes is the server in this service, but the main tool, if you're familiar, or maybe not, but there's a command line utility called, and there's a big debate whether this is kubectl or kube control, but it's but I've heard kubectl is kind of there. I don't know, Claudine or Gregor, what's your term? Kubectl or kube control? I guess that's a big. What's your?
I would say kube control.
Kubectl is a lot cuter though. So
there you go. Kubectl. There you go. So the kubectl command is the interface that developers and DevOps people would interact with the Kubernetes environment. So you can see there's a lot of basic commands, creating things, running things, getting things, and we're not going to get into all these things, but some of the main features in my case in Kubernetes is a stack. So if we do kube control, get nodes. We didn't really talk about this. So underpinning your Kubernetes cluster is one-to-many nodes is the term, and that could be in the case of AWS, it's EC2 instances that make up your pool of underlying nodes, and so it's on those nodes that then run the Kubernetes processes, and that's where your apps then run. So in my case, I have just a single node, which is this EC2 instance. And then when I look at, there's another important thing called, and I'm using some of the shorthand, I can say name spaces. So the way Kubernetes kind of partitions the different areas and they can be controlled is you have these kind of the term is namespaces. So you have different areas of the system. Some are built in. So these kube, public, and system are kind of built in with Kubernetes. And then, Dynatrace, when we roll it out, it has its own namespace, and my demo app is in its own namespace. So just to show you my little app, so we can say get I'll just show you a little trick I do because I'm there's a feature in Linux where you can use something called alias. So if I do k equal, I'll just kind of show you a tip if you didn't know this, kubectl, right? And if I say that, right, now I can just type k and I don't have to type kube control every time. So
SP Logan in the chat
awesome.
is totally a proponent of that also.
Okay, there you go. So I do have a couple more just to show you because I'm going to do some shortcuts along the way. But in my bash profile here, we can put these in the chat if you want. But I have a couple of other ones because I have a namespace called demo app. So I just call that KD. See, here's another one. Like when I do directory listings, I do like LL a lot, because I don't want to type ls-l because I'm just bad typer. So anyway, so if I go KD now, so now if I type KD, you know where that comes from. It's me not having to type that all the time. So KD get pods. So I've already in advance rolled out a number of these pods that are now running in my environment. And so these are the containers that Claudine was mentioning earlier. So the inside the pod is the container, but in my case, this little one of one, it's telling you that there's one container available out of one that have been configured. So sometimes you may see like 3 of 3 because that meant there's 3 containers running in the pod. I'll just show you how you look at these types of objects, and then I'll show you how they actually get created. So I'll do the KD again. Then I could do a describe pod. Type that one. I'll just do a more. And so what you can see, this is sort of the information around this running pod in Kubernetes. So there's a lot of stuff, like some easy stuff like the namespace it's in. This is that IP address that Claudine was mentioning earlier. When I configured it, gave it like a label. So it's like not like a tag, but in Kubernetes, the term is label. So I made a label called app and gave it a name. And then and then the image. So this is when you build your code. In my case, I was using Docker as my image format. So I have a Docker image, and this is the image name. And then that's what's running in this environment. And I also created some environment variables that are a way I can pass in sort of running data. Because what's important to note is a container is a compiled piece of code and it's a binary object. And so you can't modify it. That's by design. So it's an artifact. So we didn't really mention Elastic Container Registry and things like that. But when you create these artifacts of Docker, you make an image and you need to store those images somewhere. So you push them out into a registry and everything gets identified by that the format for, in my case, I'm pushing it to Docker Hub, which is a public repo. So this is called a repository name, and then this is the image name, and then you can have tags on the image themselves. So it's a way of versioning your image. But since you can't modify it, then you can pass in things at runtime when you run it up to pass in arguments, or you can set environment variables that can then be referred to by the code itself. And this is where the agent technology is important. So if you wanted to put an agent that's monitoring your code, you may have, we don't want you to have to like recompile this Docker image because you could have hundreds of them and you don't want to do that. So that's where Dynatrace is just by virtue of installing the agent in the Kubernetes environment, it will automatically see that you have this pod running, and it'll automatically see it.
Rob, we're getting a shout out in the chat from Dang Tank TV, likes the way that Dynatrace does a great job spitting out instructions for any language that you need. He says it's just very simple compared to the competition. Right. And he He says he works with a lot of APM tools, and he has played around with Dynatrace, and he says it's very nice in terms of agent deployment. So yeah, shout out from the chat.
So well, thank you very much. And I'll show you, that's part of my demo. So so my setup, so let's just kind of walk you through this. So in my setup, as you see, I've rolled out this sample app with a couple pods, and we're going to look at it. And then we're going to show you what it looks like in Dynatrace. And then I'm also so I'll stop there because hopefully I have time to cover all the things I want to cover. So this is what it looks like in the Kubernetes side. And then just to show you one last thing, let me clear my screen. So when it comes to the Kubernetes, I've also created these services that Claudine mentioned. So we have a get. The shortcut is get SVC, which is service. So in my case, there's lots of ways to do it. This is great for demos, probably not the way you'd want to run it in production, but to simplify it, when you create a service, there's different types of services. So I chose a load balance. So in front of every one of my individual services, so I have 2 web apps and a chain of different web services. So what I did, just to make them publicly available, I made them as a load balancer, and this is sort of the power of AWS. It made an elastic load balancer public URL for each of the Kubernetes services. So the service and everything that Claudine mentioned. So if I was to pick this service, now let's look at this real quick. So describe, so again, this is the term, describe, SVC, that one. We'll pick the first one. Let me just do more, so in case it's a lot. Actually, not a lot, but see, you can see here, it's always like organized by namespace, right? And this is that selector. So what it's saying is, for this service, find any application that has this, this label. If you remember from our previous when I did describe of the pod, it had a label called app equal that. So now the selector is look for anything that has app equal that, and then it's type load balancer. This is my inbound or public way to get to this thing, and then and then it's also identifying what port am I listening on, and then what is the target port. So this is kind of another detail. So when you spin up a service of your container, you expose your running pod to listen on a port. And then this service, in turn, also is saying, I'm going to listen on this port, and I'm going to point it to the port that is the service that the service is listening on. In this case, it's the same port. So my service is listening on port 8080. My target port is port 8080 of the running pod. I'll just show the pods again, just to show you that get pods. So if you notice on the do dash wide, there's another switch. It's just.
While you're getting your pods, Rob, you mentioned a term earlier, and I think it needs to be explained. You've mentioned sidecar. What is sidecar? Yeah.
So, it's kind of a little more. So it's a concept in Kubernetes. And maybe that's more the nickname. I think the official name would be called daemon. There's a process called daemon sets. So there's a way to attach into your processes different things like agents running into your app. So sometimes they do this with like security tools. So in the case of Dynatrace, we're basically attaching it into the service itself. So it's really a mechanism under this umbrella called daemon sets. And I think we put a link in or maybe you can add that into the session. There's a great web page on Dynatrace for showing. Actually, maybe I'll just pull it up since you had to ask the question to explain. There's a nice picture here. This is the Dynatrace documentation. So what's and again, this is getting a little deep, but what. If you read this page and how it kind of works, it's how Dynatrace is working on the daemon set model to attach things into the running app. And then we built something. Kubernetes also has another mechanism called the operator model, which is a way of managing the daemon sets themselves. So we wrote a mechanism to called the one agent operator, which then runs in Kubernetes to then manage automatically the daemon sets. And it does things like allowing the agent to be updated automatically. So it's communicating back to Dynatrace, your cluster, to say, do I have a new version of the agent? And it can update that, for example. And then the operator itself, kind of to get even more fancy, there's another way of managing things in Kubernetes. We're just doing the real simple, just deploy my things. But there's another sort of framework for deploying things called Helm charts. And so again, there's a lot to learn about Kubernetes, but that's why the Kubernetes.io is a great resource. There's a lot of great YouTube videos to kind of understand all of these terminologies of daemon sets, operators, pods, services. It's I'm learning myself every day. It's a lot to learn, but hopefully that answered it. What it does, and I think again I'll kind of more demo what it looks like here. So just to show you Dynatrace, how it is installed in Kubernetes, we'll say, and I'll look at the namespace Dynatrace. If I could type, that's what you can see why I do the shortcuts. Get pods. So what's happening is running in the Dynatrace namespace is this one agent operator process, which I was mentioning, and then it sees that there is one node, which is remember the cluster could have one to many nodes in the pool, but in our case we just have one. So it basically installs one agent running on the node, and everything that's in that node will be automatically seen by Dynatrace. So let me flip over to Dynatrace, because then maybe it'll be more clear what it looks like at Dynatrace. So Dynatrace itself has a web interface, and that's the primary tool people are logging in and seeing. So in my case, I'm logged into it, and when we'll share the links at the end. But if you try Dynatrace, we run on two modes. And this is the part of the great partnership with AWS. So one, we offer Dynatrace as a SaaS offering. And so all those SaaS clusters of Dynatrace. So Dynatrace itself is a website. It's a cluster of nodes that collect all your data. All the agent, as they're collecting the data, send it to the centralized Dynatrace cluster. Terminology we use is tenant sometimes, but essentially think of it as the Dynatrace cluster. Everything's coming into one place. And so this web UI is what we're looking at, is sort of sitting on top of the Dynatrace cluster, and that's where we can see things happening at Dynatrace. But that cluster itself, to go back to that point, can be run on SaaS. And if it's run on SaaS, our entire SaaS offering runs on AWS. So that's kind of where Dynatrace uses AWS as a core technology internally, and we built our entire SaaS offering that runs on AWS. So it's powered by AWS anytime you run Dynatrace SaaS. But Dynatrace can also be installed, as a product on premise. So a number of people have restrictions or have had restrictions in the past where it needs to run in their own data center. So Dynatrace can run on servers in your data center, but also Dynatrace can run on provisioned infrastructure in AWS. So there's different ways of deploying Dynatrace, the environment, if you will. So with that said, let's look at what we have in our environment, or my demo environment rather. So again, I have kind of an empty environment. So what we're looking at is a host, which is my cluster host. So if I drill into this now, so this is what the one agent is automatically picking up. So all these dashboards that I'm showing you are just ways that Dynatrace has constructed the web UI to give you these views into different aspects of your infrastructure and services. So this here is now we're looking at that cluster node that has got instrumented because the one agent operator put it out there for this node to be picked up. And so at one level, we're seeing all the things you would see at a lower level infrastructure of an operating system, CPU, memory, network cards, disks. And so this data you would expect, from a monitoring tool, time series data. You can change the time frame over here, what window of time you want to look at. But what the power of what it did was it automatically picked up all the processes that were running on this host. And so in this case, we were running are running Kubernetes. So pretty much everything that we see are these Kubernetes containers that are running kind of in this cluster. But before I do that, I'm just going to show you this, what I mentioned earlier, something called the Smartscape. So what the agent also did for us, and this is all automatic. And if we have time, I'll try to install an agent on another machine and show you how quick it is and how fast it picks all this stuff up. But what happens is this is our stack of how we view how the product of Dynatrace builds a full stack of your environment. So you starting at your data center, so you can see down here, I'm in AWS. This is a host running on it. And then it automatically pick up all the processes that were running on that host. So I can expand some of this view. And so yeah, you can see, look at all the stuff that's running on this particular host. Now, some of these, because I turn my environment turning on and off, some of them are no longer active, but you can see, how this this view of your vertical stack is automatically picked up by Dynatrace. So when you come into an environment, I don't have a whole lot here. Let me just maybe pick a couple more. But when you have an environment made up of many processes and what's talking to what, this is the complexity that I was mentioning earlier. So in our case, we have one app with one thing, but just we have in customer environments where this is thousands and thousands of things. It's unbelievable, and we now have to manage that through judicious use of tagging and things like that to be able to filter out and manage complex environments like that. So if I go back to, and I'll just show you one thing. So I'll go back to our host that we were just looking at and show you kind of what things that also came in automatically. So first I'll show you AWS real quick, go back to that. So if I go to AWS, back to that same host, I just want to show you sort of just how basic information came in. So for this cluster, if I look here, for example, you can see things like, if I can stretch, things like I built a couple of there's AWS tags associated with this. Some of them automatically got created by the use of the wizard. Basically, when you create a cluster, a lot of these come automatically. So I didn't really make a lot of these. This one here is interesting. We had a tagging rule automatically made on the AWS side to say ACE stands for that's our DevOps team. It's Autonomous Cloud Enablement Team, and so that automatically came. I didn't make that. They did that. And so this is in your organization, things like, configuration items, app team owners. You may have configuration management tools that are putting all these tags in here. So you made a big investment to build all these tags and build a tagging strategy for it. So then on the Dynatrace side, all those same tags are all also automatically going to come in to environments. So then they can be used to drive filters on dashboards, security access, different views, and et cetera. But all of this information you can see came in automatically from the agent as well. And so since we care a little bit more about the app, so that's kind of a bit about kind of Dynatrace and the raw data, but let's really talk about this app now. And so how it came across in my case, so let's just show the app again just to show you it. So this is my very simple app. So remember from before, this is my Elastic endpoint that I have, and I have kind of two instances of the app. I have app version 1 running on port 8090, and I have it's over here, sorry, wrong tab. I have version 1 of the app running on port 8080. So I have basically two apps that are, and the way this app is kind of built is it's configured so that it will call the web service. So what it's doing is it's saying, hey, I'm going to call this other web service, and the response I got from this web service is this data. Let's take a look at what one of those actually looks like. So this is also the Elastic IP of that same service, port 8080, and he has an endpoint called API message who tells you who he is. He has a couple other APIs, like I have one called about, that will tell you, information. So when I built the container, I built a file that contains all this information. So it's almost like the manifest of the running image. And so that's where this app is now running. So this app 1 and 2 are calling the same endpoint, and now you can see it here. So now in Dynatrace, you can see we have another view, which is called the service. So it's picking up the fact that we have, and let's just pick the web app itself. And so let's do this. So again, this view is automatically built by Dynatrace. And so the way you interpret the kind of the cool things about Dynatrace is so it for this service, and if you look on this top part, it says that this application, this web application 1 is interfacing with this app, and then this app in turn is calling these other services. So this web app is calling simple web app service number 1. And so that's one. And a way to visualize that is we have something called the service flow. And I'm going to show you something cool where it picks this up dynamically. So it's nothing too interesting.
Hey, Rob. So
yes,
what
sir.
kind of instrumenting did you have to do to get that visibility on that application level execution?
0. Honestly, 0. So
you have to say that again for me, because I'm trained that I have to manually instrument my code if I want any meaningful level of observability.
Yep. That's with the power of Dynatrace. So literally, we and so I'll show you a little bit more. Then I'll show you real time how it picking up something with no config whatsoever. So what we're looking at in Dynatrace is this flow where and let me just see if I can get my. Yes. So what we're seeing here is my web app is calling my web service number 1. So this is not too interesting. So I'm going to show you what I have as a feature built into this app real quick, and then it'll look a little more interesting here in a second. So what I have is for this app, I have the ability to configure what each web service is in turn doing. So in my environment, as you remember, I had web service 1 to 5. And so what I'm going to do is I can configure so what I'm doing is I have another web service running on port 80. So if you notice, web service 1 is running on port 8180, web service 2 is running at 8280, and so on down the line. So I'm going to configure the web service on the fly here to adjust this, and I have to do an encoded string just the way it works because it's a GET request. So now I've reconfigured my message to the service to then point to another. So if I come back to message now, so what I just did is, and I built a chain of these commands. So now my web service 1 is calling web service 2. Web service 2 is configured to call web service 3. Web service 3 is configured to call web service 4, and so on down the line. And so now if I go back to my web app built into the screen, you can see it automatically got refreshed because just the way the app was written, I just output what was the response of what I called. And so now the web app is calling this chain of different things. And that's what we're interested in, is like, now just imagine the scenario like, oh, I created a bunch of new services in this sprint, and now my app is like 5 services, not just 1. So now if I go back to Dynatrace, let's see, magic drum roll here. It may take a second to pick it up. Oh, there you go. So now web service 1 called 1, which called 2, which called 3, which called 4, which called 5. So I didn't do anything, right? I just made my app change, and Dynatrace automatically figured out that behavior. And so that's pretty neat. And so what we can do here now is, and just while I'm on the screen, one of the things about what Dynatrace is doing in this service flow view is we can look at it kind of from different dimensions. So it's not too interesting, but hopefully you get the idea. So I have a response time breakdown where I can see where from the originating call, where is time being spent? So I can see that most of the time is invoked to get to service 1, but then once I'm into these other calls, they're all pretty quick, and so the time is really primarily in this service here. I can also look at from dimension of throughput, so it's going to be pretty much 1-to-1. Oh no, it's not actually. Interesting. So it's so I have 3. Oh, I think a lot of this breakdown is because of the I just switched it, and I'm looking at a time frame of the last 10 minutes. So if I was able to kind of tweak this to say if it lets me do the last, say, 3 minutes. see if I can get yeah, so there we go. That yeah, I'm still in this frame where most of the traffic was. So in a couple of minutes, this will all even out where every call is being called in the same amount. But then I'll just show
This is
you
what happens
kind of
when
another.
you go live. Just part of the
well,
deal.
it's not really live. I switched the time frame so fast. So what's happening is it wants to look at a 10-minute time frame by default, and then so those are kind of being counted up in aggregate. And so remember when it was first hitting service 1, that counted, say, I'm making a number up, 300 requests, and then only a handful now go for the full chain of requests. So it's just sort of the way it's mathematically working out. So if we wait a couple more minutes, this will kind of even out. There we go. See now, next time frame. So to 60, 60, 60, 60. And if I do the response time, it'll probably be now more even too. Actually, because so basically what's happening is each service is the same code, so each adds a little bit of time. So as you notice, it's like it's reduces. So this guy's adding 16%, he's adding the 16% plus this guy's 16%, so 30%, so on. So you can see a nice view of the breakdown here. And so the reason I'm getting traffic, I don't know if you notice it, but I have a little utility in my browser. These are great utilities, by the way, for testing stuff, where I can just have it automatically refresh my page. So I'm like refreshing this page every couple seconds here for both apps, and that's how I'm seeing some traffic in my environment. So other ways to see things in. So if we go back to the service itself, let's go ahead and look at the. Let's go back to the service here. So we'll look at the web service and just see some more details about it. So if I pick this web service, so this is running on, so what I'm looking at is this is the container. So if I expand some of the details, you can see all the details that kind of came automatically. So maybe zoom in just a touch, maybe really small for you to see. But let's just see some of the information that the Dynatrace picked up. So we've got all the Kubernetes metadata. We can see the container image name. So everything about your app is kind of at your fingertips here. And so when I spun up the app, I kind of passed in kind of custom data, so I knew who it was. And so this is maybe another feature of Dynatrace to kind of highlight about the dynamic nature is when I pass in information to my pod, in this case, I can then build a rule to then build tags for that service. So if you notice here, project demo, service, blah, stage, whatever, I then created tagging rules to say, if you see a label called project, grab the value and make a tag called project demo and so on. So now that I have this, now this is where automation can really happen in Dynatrace to say, hey, let me build a dashboard that shows, all things related to this demo project, for example, or show me everything that's in production, show me everything that's in stage. So now instead of manually configuring this IP address or this host, you let Dynatrace do that. So there's an extensive set of configuration options around this automation. And I'll just show you the rule real quick for that particular one. So when I have a project rule, I can say, edit it. It's like basically look for, when you see a service, host, or process, if you remember that hierarchy, and again, mine's super simple, but it basically, if I see an environment property called project environment, it exists, go ahead and build a rule called project, and the value of that is, in this case, this is a placeholder. There's a lot of built-in values that you can pick from. I just happen to pick that one, which gives me the value I need to then build that tag. And so what the tags are super, super powerful when we start doing things as developers. So when you want to, so all of Dynatrace, just to kind of show you, because a lot of developers on the call, there's a huge API available, and I'll just show you. There's a Swagger API built right into it. So if I wanted to look at, say, we'll look at the configuration API as an example. All of those things like the tagging rule can be built with, let me see if I can find the tagging, right? So I can build all those tagging rules by an API call. So when we start doing, so as we move to more advanced infrastructure is we want to do your configuration as code. You want your, and this is part of that configuration. So there's a configuration of, hey, I want to maybe have a, maybe I'm using Terraform to provision my infrastructure, or maybe I'm using Ansible then to layer on my configuration and components. Well, Dynatrace can then also fit into that same framework, because now you have APIs to then do that configuration. So if you onboard an application, you can have automatically created rules for tags, for permissions, automatically make dashboards. And this is really opens up the power of Dynatrace, is all of these, the ability to have APIs. So when we want to look at environment information, all of that metrics data, now we have we have a way to query all this time series data, and so you typically do that with these tagging rules. And so the tagging rules all come from the tags you have. So you could say, if I see this tag or that tag or this pattern match, could be any Dynatrace tag, it could be an environment tag, it can be the AWS tag, any tag that came in. So the tags are are central to Dynatrace in terms of scale. And that's the real power of Dynatrace as we start managing more complex environments. So now that I've run some traffic through my environment, if you remember, before we only saw a couple of these services, but now we see all these different things happening here. And so another way to reverse engineer it is, let's pick the bottom of the tree, which is service number 5. And we can go, before we went kind of top down, like, who do I call? But now let's look at a feature like, all right, who calls me? So if we click on this button, now we can kind of see a cool feature where I'm service 5. I'm called by 4 is called by 3, you can kind of see it. But then at the bottom now you can see my 2 apps, app 1 and 2, both call service 1, which then drives all this traffic this way. And now you can see, some metrics at this level as well. So this is kind
We're
of
getting some questions and comments from the chat, Rob. Again, from Dang Tang TV, he was commenting about how you can also hook this up to your Kubernetes cluster to get your cluster metrics. And people are wondering if Dynatrace actually ingests CloudWatch.
Yes. Yep. Yes and yes. So yeah. So let me show you that. So everything we've been talking about, or I've been showing, is really around the application and the application transactions and how it fits. But managing your Kubernetes cluster is depending on your role, everyone should care about it, but not everyone's necessarily responsible for managing the Kubernetes cluster. But built into Dynatrace is specific support for Kubernetes. So I've configured my environment to point to that same cluster that we've been talking about. So we have sort of a purpose-built dashboard here that lets you visualize. And again, if you had multiple clusters, you would get all the clusters that you configured it to. And if you had an on-prem cluster that was an AWS, you would see that. You would see any EKS cluster that was provisioned this way. If you install Kubernetes on top of EC2 instances and want to manage the entire thing yourself, outside of Kubernetes, outside of EKS, you would see that. But anyway, the way we visualize it is we think of things as the cluster. So the cluster is made up of, in my case, I have a single node, but usually it's a big farm. It could be, a lot. I don't know. Gregor, I don't know how many of you've seen, but I mean, they can get big. You can have 20, 30, 50 nodes that underpin it. And that's why Fargate exists, because you get to a scale where you have so many pods and your cluster is so big, leave it to the engineers at AWS to manage that instead of you. But anyway, so the cluster here, you can see at a high level, and this is all the terminology that Claudine was mentioning earlier around Kubernetes. So there is this terminology to learn, like namespaces. So I showed you guys the command line way of doing it. If you remember when I said kubectl, get namespaces, these are the namespaces we saw. So again, in Dynatrace, it obviously picked them up automatically. So if we pick on the one where my app is deployed, this namespace, now I can drill down and then see, this is just, again, a visualization of running that command now, like get pods in namespace, demo app dev, right? So now I can see that. So in my case, now the app that we're looking at, again, typically, as you're running multiple instances of a given pod, one for kind of availability, but that's kind of what Kubernetes will do for you. So you can define as part of the deployment, how many what they call replicas do you want of this particular thing, and then it's kind of managing that within the constraints of resource like memory that you've allocated, kind of a detailed point, but you would normally see one-to-many of these. In my case, I just have a single app that's kind of running here. And so now once I have that, I can now see some, again, this is all kind of in the view of kind of thinking about it at the Kubernetes level where I'm more interested in the infrastructure. I can see things around just the processes themselves at a kind of an aggregate level. In my case, it's not so interesting because I only have one instance, but that's where you would see it. Other things within the dashboard while I'm here is then health around the cluster itself. So we would see everything you see here: requests, around the CPU, memory. You can do further analysis of the nodes. You can have sort of a time series view. If I kind of change the time frame, maybe couple days, then you can see, again, I've kind of kept it running for a while, but you get the point. You can see kind of what's been running in your environment in terms of utilization. And then what else can I do here? I'll enable something with this events. Actually, maybe I'll do it while we're talking. So I built another app for demo purposes, and let me just change it in my directory, and I'll show you how this may be a good segue out of deploying the app again in the environment, and now we can see how it shows up in Kubernetes here. So my simple web app, I think I called it the bomb app. And so what I'm going to do, actually, this may be another kind of quickie lesson on Kubernetes. So I have a very simple Python program that I wrote. I'll just pull it up real quick. Doesn't do much. So what happens is it's going to basically create an instance of my class, which is this boom app, and then it's just going to call the process method. So what the process method does, it just says, I'm going to go ahead and I'm going to make a call out because I use this requests library. So it's going to make a request out to Dynatrace. What the heck? It's going to wait 30 seconds, and then it's going to make an instance of this bomb class, and then call the boom method. And the boom method, if you notice down here, is just going to raise an exception and it blows up. So basically, you run the code, waits 30 seconds, and then it blows up. That's kind of the purpose of it. And then just to show you Docker, because we were talking about containers, the way you build that code, which is Python, into an actual image. If you've never seen one of these, I'm going to go real fast, but the underlying concept of containers is you have a base image. It's not quite a full operating system, but you can almost think of it like an operating system that then can be layered on with other utilities and programs, and then it's highly optimized so that it doesn't take a lot of room up. So what I'm choosing is there's a pre-built public base image that has Python version 3 running on it. So I can just say, hey, and it's Linux, so give me that, and then I can set up a couple environment variables, and then I copy in my Python script. If you know Python, there's a thing that you also copy in, which installs all your packages that you're dependent on. Then it runs the utility to install it, and then when you launch the container, it's going to run that command. So when you say run the Docker image, it's going to run that command, which then, if you remember, will blow up in 30 seconds. So, and then just again, so then the way it gets deployed, I'll just show you the YAML file, which is how I don't think there's any other way of saying YAML. Gregor?
YAML. That's all I've ever heard.
There's no controversy around YAML. All right, so it's YAML. You've never heard of YAML. That's YAML. But if we look at that file, and this will let you see what one of these Kubernetes things is. So this is kind of a simple one. So we're saying, and so when you look at these YAML files that you ask Kubernetes to run, they have this kind, or they don't want to use the word type, but it's a kind of thing, kind of object. So there's things like a service is a kind, a deployment is a kind. There's different kinds. Deployment is what we want. So what we're saying is, and here's that replica. So we're saying, hey, I want one instance of my thing when you make a deployment. And then what a deployment is doing is, so deployment's a special type of object in Kubernetes that says, don't just run my pod, I want to create a definition of what I want run, and I want one instance, and I want this image run, and I always want to re-grab the if it reruns, always re-pull down the latest version of the image, give it a name, and then that's the definition of a deployment. So the way you run these things, and I'll do the spelled out way this time, kubectl apply. There's two different, you can use create or apply. I always kind of just use apply. And then what's the name of my file? And I'll do boom app. Okay. So now that what that did is it told Kubernetes basically create that deployment file, right? And it went ahead and made it. And it's going to do that. Let me just see. Oh, that's right. I didn't tell what namespace for it to run into. So by default, Kubernetes has a default namespace. So I think if I say, I meant to do it in the, actually, I want to put it where I want to put it. So it shows up where. So here, what we can do now is this is another feature. I can just say delete. I could type, delete it. So now it'll delete it. What I wanted to do was put it into the same development namespace. So just rerun that same. Here, let me just clear my screen for you guys, make it easier to see. So if I apply that, I can say namespace at just another argument. So just put it in the namespace I wanted it to go. So now if I say KD get deploy, so if I look at my deployments, I now have that new one called boom app. So and these are all the other deployment objects which create the thing. So now if I do the KD get pods, now I can see this guy there, okay? And what I'm going to do is there's another thing called, let's watch. Yeah, so this -w will keep it running, and then it will refresh it if the app, and you can see it's run for 31 seconds. So if the state of something changes, it should show up on my screen. So we'll give it, yep, there we go. So now the boom app got into an error state and it blew up basically. And now it's rerunning again, okay? And if you notice, it still has the same container name. So if we look at that, and let me just clear the screen, and I do the KD logs, KD logs of that thing, you can see, the output that it did. So it's like, I just do follow. So we'll just follow it. So now there you go. So yep, caught it good in time. So it's like the code kind of ran, it slept. Remember, I called the URL Dynatrace. It slept for 30 seconds and then it boomed. And then you can see here, boom, 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 boom. I'm blowing up. It blew up. It's dead. Now it's dead in the water. So now let's see what that looked like over here. So hopefully this will be my drum roll for my live demo. Very good. So Dynatrace, so part of Kubernetes, it has something called Kubernetes events. So this has nothing to do with EKS, it's part of Kubernetes. And so Kubernetes is pushing out all sorts of events, like I pulled images and started stuff and I got errors and whatever. And so this is what Dynatrace can now show you kind of in this one dashboard. All the same data, you can run through a bunch of command line commands to kind of figure out all this stuff. But this is the power, this is why you want a tool. So if you had a bunch of clusters and tons of stuff, you can't be looking at all this command line stuff, unless you need to drill into some specific thing once you knew what it was. But this is what the Kubernetes dashboard can do for you. So in addition to seeing the cluster health and the running pods and all the namespaces, you can now also get these Kubernetes events that are tied into here. And then just to show you a little configuration detail of how you can do that in Dynatrace is we can do that if I do it right. Yeah, Kubernetes. And so my cluster, I don't think there's any secrets in here, but what I can do is I have a lot of control, I guess is where I want to show you. So you can control different, there's basically a whole, like they call it field selector language. So you may not want every single event in your whole environment because it would be like way too much. So you can control, like, I want to go after certain types of objects or have certain types of names in these, that I'm caring about. So in my case, you can see here, I only cared about the pod, and I only cared about my namespace. That's why I wanted to put it in that right namespace, because I knew I had this configured. So it would only be looking for events that are of type pod in that namespace. Those are the events I cared about. And then, of course, I cared about any major node-related problem, which is my cluster health. So that's where.
Can we set alarms based on these, or are you going to make us go back to CloudWatch?
No, at the moment that is coming. So I wish I could tell you yes, but the answer is no. So the Kubernetes, this event was recently added. And so I think in an upcoming sprint, that's what's happening. So a lot of it is there's more and more demand for Kubernetes, and so now we're prioritizing a lot of our app dev within Dynatrace, our core product, to keep enhancing that. But the good news is around Dynatrace is we're on a model, and this is, so I don't know who may be on the call that's been around for the last 10 years, but Dynatrace had a product called AppMon, which was really was a heavyweight, thick client, wasn't made for the cloud platform. And probably, I'd say 6 years ago, they made a decision, Dynatrace that is, to completely re-architect and completely rewrite Dynatrace from scratch. And so as part of completely rewriting it from scratch, that's why we now have a new UI, we have completely new agents. So unfortunately, you can't upgrade from the old Dynatrace to the new Dynatrace because it's new agent technology. But by having this new data model with the streaming of data, the metrics, the AI engine, that's all now the new Dynatrace. So if you've been around for the last 5 years, that's maybe all you've known is the new Dynatrace. It doesn't have a product name. We just call it Dynatrace. And so anyway, so Kubernetes is, and so as a part of that transformation, where I was going is, we release software, Dynatrace that is, every 2 weeks. So there is, we've moved way beyond the model of, you get a major update every 6 months. That used to be how we were. So any modern company, just like AWS, right? You were delivering software continuously. In our case, we deliver new functioning code that's ready every 2 weeks. So it'll be continuous incremental changes all the time. Is what I can say. So that's what's cool about it. And so this screen, I know, has some new enhancements coming that I'm aware of already. So some of it can be navigational things, like I can just making it easier to navigate from this screen, so I don't have to click so many times to go over someplace. Our whole API, as I was showing you earlier, if you can notice, we're going from a version 1 API to version 2 API. So we're like constantly throwing out new endpoints of our API pretty much every sprint. So this is really kind of exciting that we have that for.
And I'll take a moment for those who may have joined a little bit later. We are here with Rob from Dynatrace, and he is at the moment giving a tour through the Dynatrace dashboard to give visibility into an app that he built and deployed and set up on through Kubernetes and EKS. And right now the app is running in its boom mode, which is producing some nice errors for us to trace into.
Yeah, let's go into the boom mode. All right, so if I go back to, there should be some more messages now that it's been booming for a while. Mm-hmm. Right. So, and then if you noticed, and this is right. So now we can start seeing like failed off container. And if you notice now, good timing, we now have a problem. So it's a good segue into our problem card. Hopefully this will be the one I want to show you. Yeah. Well, this will show. This because the app. While I explain this, let me just trigger the other problem, which gives a more meaningful problem here. Let me do KD get SVC. And so again, what I'm going to do in this case, I'm going to take service number 5, which is this URL. Let me come back to my browser and put a different URL. I'm service number 5, which is port 8050. So if you notice, I'm number 5, and he's kind of the bottom of the chain, so he doesn't call anybody. But what another feature I can build into the app is an error rate. So I'm going to put in an error rate of 100%. Let me zoom in. Probably hard to re-see that. So what I did is I called this endpoint, so it's kind of built in, so I can set it to 50, but let's set it to 100. And then so if I call, so if I ask who I am, which is the message URL, he will, if I could type message, now you can see I have an error rate of 100. And then by making that error rate, he, instead of returning back a 200, I'm good, it's now returning an HTTP 500 and just faking out an error. So it's like a built-in feature flag where I'm like, go ahead and blow yourself up. So now if I look at the front end app, now, I'll show you kind of the developer. Hopefully you guys all know this tool. I'd hope so. But this is the developer tools. And so I can now, as I'm refreshing my page, just to show you it is a 500 error. These are HTTP 500 errors that are coming back as the page is requesting. And, I'll kind of pause it for 1 second here. If you kind of watch closely, so at the bottom of the chain, he is the error. And then that 500 error is being bubbled up to every single service because he tried to call something and it basically carried up that's just the design of this demo app. It carried up that 500 error all the way to the front end. So the front end now is, not happy. It's blowing up. And part of my fun, and I'll do sort of two modes, I can kind of hide that detail. Oh, crap. Sorry. Actually, I'll do it this way. It's fine. Stop this timer. So I can show a mode where it's like, show me that detail or not. So that's all I did. Just add a query string. And this was my fun. I don't know. Actually, Gregor, I give all the credit to Gregor. So, the fun we had planned for you guys was like, I have this error, right? All I know is my app blew up, and I'm getting 500s, but I have no idea where is my error in this chain of commands. So, hopefully maybe some of you seen Jurassic Park. We couldn't violate them, but we had fun with that anyway. So my app is now throwing a bunch of 500 errors, and then again, if I look at the the actual service itself, you can see it too. If I do that, more tools, developers, it too is. If I make it refresh. Is also calling 500 errors. So at this point, every call in my app is blowing up with a 500 error. So if I look in Dynatrace, so it may take a minute for it to manifest in Dynatrace. So that's why I may come back to this problem. But let me just show you real quick. Let's duplicate this tab. Just to show you that the service is now starting to be having a problem. So if I go to my simple web app here, right, let me just change the last 30 minutes. What I can see automatically now is my failure rate starting to go up, right? So if I look at this, drill in, I can see my time series data. So I'm starting to get, so this blue, it's not the red lines, it's actually this blue line. So the blue line, it's the scale. So the one on the right is the number of requests, I think every 2 minute kind of scale, right? And then the thing on the left is the percentage. So this blue line actually is I'm getting 100% errors starting like a minute or two. So we'll let that run for a minute. Oh, it actually started to show up as Dynatrace problems already. So you can see Dynatrace picked that up already, that my failure rate was exceeding what I wanted, or the AI engine detected it should be. And so let me go to my problem cards. And now we got a bunch of problems. And we're going to see how Dynatrace will, once it finishes processing these things, we'll see that that they're all related and combine them all together. So just take a minute for them to combine. But while that's let me do that. I just wait for a minute. Was there another question before I give this a minute just to process that I can maybe answer? Or if not, we'll just be patient, I guess.
I think we're good in chat right now.
Okay, so what's happening is, Dynatrace first of all figured out that there is an impact here. So in this case, I just clicked on the one that's web service 2. So I had a threshold just for demo. So normally the AI engine would collect would have history. Since I just set up my environment, I only had like an hour worth of history, which is not enough to inform the AI engine. So I can configure, if I needed to, I can do overrides within Dynatrace to say, you know what, I just want to set a fixed threshold for this, and that's what I did. So I just said, if you see errors above 25%, make it a problem. And that's what I did for the demo purposes. But it's now, because it has to collect some more data, it's still kind of in this processing mode of calculating that, what else is it related to? So if we give it another, I think it takes 4 minutes for it to process. And so you can see I have a bunch of little problems here from there. And let me look at the web app. So this is the web app. It's also having a problem. And that's where we just were. The failure rate's 100%. And if we look at the service flow while that's kind of going, we can see, again, it's starting to color code things and seeing problems. So let's just give it a second. Yep, now it's starting to mush it together. So see that? So now it said these 5 services are now all related because they're all in the same tree. So see how it dynamically figured out, like, hey, 1 calls 2, which calls 3, which calls 4. Now I have multiple impacted services. And it's already starting to see the root cause of all these impacted services. So if we give it a second, if the demo works, it will now mush the 2 application problems too, hopefully. Here, that's the drum roll for the demo.
And so you did not manually set any error threshold for this. It's the AI engine that detected the anomalous rate on its own and surfaced it up when it became clear that it was a problem?
Yes. Well, I'm going to say yes and no. I'm going to say yes for yes, that's how Dynatrace works. You don't need to adjust things. But there is, built into the main global config there, and I'll just show you what the default kind of is, which I've overridden. But normally, so I did it for demo purposes, but let's just shoot. If I hit reset, I'm going to lose my demo here. But basically what happens is there's a setting where it'll automatically look for behaviors in its known history. And then it will, again, I'm using the fixed, let me just, I don't want to mess with this right this second because it'll break the thing that's the error that's running. So Dynatrace does this, but for the demo purposes, because I didn't have enough time to get history of these running apps, I forced it to fail. So I've said, if you see a failure rate of 25%, even if it's super duper low volume, go ahead and just, cause that as a problem. Normally you leave these settings alone, and if it would be more an exception basis. So if I went into a particular app, I can go in here and edit it at the service level and then override those behaviors, right? So I can come in here and so here's the automatic. So the automatic rule would have been if it degrades more than this range, right? And it's not too much volume or not enough volume, and you can have other rules configured to really refine things. This is normally you just kind of leave the global settings and let it do it. For demo purposes, I overrode the global because I only have like one thing running in my environment. And you can also, there's a lot of refinement around all sorts of, if you have an app that just, because you don't want a lot of false negatives. So when you get into a more production environment, there could just be, it's a known problem with this one JavaScript that throws error, and we know the sprint's going to come. So instead of getting alerting a gazillion times, we can, you can program in exceptions to how things are detected as problems. And that's okay, but by default, though, you don't have to do anything because it's going to have a default behavior of looking for what is normal for that particular app. And you can see like there's a reference period. So normally it wants a reference period of 7 days to get a real good baseline of data. And then it's from there, it triggers things. So hopefully that answers the question, but it looks like our problem mushed together. So if we now look at this problem, now we can get that hierarchy and see kind of a couple things going on. So this topology, again, I didn't do anything. It kind of knew that was the chain of calls. Okay. And then what's interesting about Dynatrace, again, it's not correlating log data, it's looking at a lot of events and doing this cause and effect. So you can see in this time frame, there was 5 events that it analyzed to see that the failure, like in this case, failure rate increase was beyond normal. Okay, what does that mean? Does that affect something else? And by cause and affecting that together, that's what the AI engine stitched together to say, you know what, all these different events of failures are all related, and so I'm going to group them together and then create this. So instead of a single alert, it kind of just keeps this ongoing problem card open, and then you can see here in the course of things, it analyzed 100,000 dependencies, which are all lots of low-level calls that the services are making to determine that answer. And so if we kind of look at the failure rate of this case, if we kind of go into that, we can have, so now like, okay, now I have some details of like what it was. So in this case, the low level was, I'm getting HTTP errors. Okay, that's the bulk of the problem. And if I wanted to like drill into the code now, again, not the most interesting code that I have here, but let's see if I look at the requests themselves, another way of analyzing things, I can see that this method, the API method itself, was having problems. So if I want to now drill into, what were my exceptions within that particular call, hopefully I'm doing this right. Nope, click the wrong button for that. Yeah, my sample app is so simple. Let me just go to, I'm just going to go to the pure path. So what happens in Dynatrace, another level of granularity, this is where it's mind-boggling. So every single request that's made is being captured. So we're seeing a lot of things in aggregate, but it has all the data of every single little call that was ever made. So you can see they're happening in, microseconds here. So if we wanted to like drill into the this particular call, this is like one call that's happening, and we can have all the data. So this is great for developers to drill into, like, all right, what happened on that one call? I can filter and find it. I can see timing breakdown. I can see, again, a lot of this is just a simple Node Express app that I wrote. So it's the error that I'm looking at is Node Express is calling a web endpoint. So it's the web endpoint that is returning a failure, and that's what it's seeing. So it's not too interesting at this code level at this point, but when you have like a Java app, you would see all the methods and the classes that were actually causing that. And I think maybe if I pull that other problem with the Boom app up, if it's still there, I can maybe show you that. So if I look at that,
all of those like crime TV shows where they gather around big computers and then they press the magical enhance button and then they get closer and closer and closer till they see somebody's pimple. That's kind of the feeling that I get when I'm looking at the Dynatrace dashboard. So
this is. Yeah, and this is where we see like it can have one tool, to really see, so I can be the front end guy, I could be the services guy, I could be the database guy, and I can all see the transaction flow as it's navigating the app. So if I'm really, and everyone can look at the same source of truth of what's happening in the environment, and just, with a couple clicks, I can see it. So if I know my component's good, or it tells me it's this web app team, and this is where you start combining it. If this service 5 is, team, if you remember my metadata here, I just, for fun, I called it, I was trying to like find like, this is the project and who owned this service. Then you could direct, because you can send problem alerting from Dynatrace from problems. So that's one of the things of Dynatrace. So you can, from a problem, build alerting profiles. You can then send problem notifications coming from Dynatrace to a variety of tools that you may have in your environment. And so all those problem details, all the problem metadata, all the problem information would feed into these other tools, which then in turn are the tools that you do your workflow management with. So, and we have some partnerships with other companies like ServiceNow. I'll just use them as an example. They built a bidirectional integration where their CMDB data that's in ServiceNow will push those tags and those CI items into Dynatrace. So now Dynatrace knows about who that particular configuration item is, and then vice versa. When the problem's created, they pull that back, and so now they know the specific configuration item that's impacted, which then maps to all of their, their escalation groups and their support teams and all that stuff. So this is kind of where we see, so that's where it fits into the broader ecosystem. So Dynatrace is great for seeing who it was, what's impacted, getting to the root cause, not getting you a bunch of alerts for every single layer of the problem, and then hopefully, letting that team, immediately act. And that's the idea. And, we have a number of some great examples, and there's some YouTube videos presented in our conference where people built chat bots with like Slack. So there's like some smart bots where they're deployed them into their Slack environment, and they really do chat ops. So those chat bots interact with the API of Dynatrace. So you can say in your chat bot, hey, Dynatrace, what's the status of my service? And then that in turn calls the API using those tags, pulls the data, packages it up, and puts it into a little Slack message. We actually have a small chat object called Davis Assistant. So we have something that can do just those use cases with the Alexa device, Google device. Those things are. We actually have something like that. That's another demo for another Howdy partner. But there's a whole thing around chat and operations now that you have all this great data. Now you leverage APIs and start building utilities around automating things.
Question from the chat. So knowing that Dynatrace can do all of this magic, what can Dynatrace not do? And this may be an opportunity for you to talk about features that our audiences could look forward to for the future. But what can Dynatrace not do? Somebody's asking.
What can Dynatrace not do? Well, I can tell you some things that it can't do that are coming. One thing that I'm actually really excited around is, and actually you were talking about CloudWatch. So I'm going to use that question as a segue to show you the CloudWatch, which I think was an earlier question. So one of the way that we integrate with CloudWatch, and this will lead into the limitation that's coming, is let me just show you how we configure it. So in Dynatrace, we can have integration to that's where we did the Kubernetes. But for AWS, what we can do is we can connect to, typically role-based is what we'd want. So we can establish a connection to the CloudWatch API. And again, these are AWS tags in this case. So I can control what data gets brought into Dynatrace, and all that CloudWatch data gets visualized on the AWS screen. So here, if I had multiple accounts, this is sort of a tile by account. So in my account that I've configured, we have this little view of some of the core services. So Dynatrace started off with more of the compute resources, and we only supported a handful of what we called supporting services. So we're now made a big push to be basically CloudWatch ready. So when CloudWatch makes and publishes a new metric, we will be automatically able to bring this in. So right now we are supporting, I think, half of them. And if there's a blog article, I think I asked you guys to put in the little chime window. There was a blog article that announced our roadmap over the next couple of weeks to actually roll out support for the remaining AWS services. But on this view, when we're looking at it, what this is doing, and just to show you what CloudWatch metrics look like, is I'll just pick EC2. So what we're going to be able to pull in is all that metadata that's exposed by CloudWatch. So in this case, I can see these EC2 instances. I can see the region they're in. I can see for this particular. It's the way this is currently built. It's all by the availability zones, and so you can see a history of running instances. And if you notice here, I can have instances that have an agent on them, Dynatrace agent on it, or not an agent on them. So if it's not an agent on it, what happens is we can bring in this object or an entity which represents the EC2 instance, and we will see everything that came across for it, including the tags, and then to capture just host level, because the EC2 is just host level metrics. So we're going to time series collect any metrics that are exposed by CloudWatch. and then we can see it. So then all this data also in turn fits into the Davis AI engine. And forgive me for just typing in one thing. Hopefully I'll spell it right. But we have a repo, and I'll put this is a link to share in the what happened? GitHub. Dynatrace has a public repo here, and what I wanted to show you is these are specifically for CloudWatch dashboarding, AWS, and because of our API, I have to scroll down to show you the pictures, but basically our API, because we don't know what services you're going to use, we let the customer decide which one of these dashboards they want to bring in. So again, you can see how easy it is. We call our URL, there's an API for dashboards, we basically bring in that object. And so each of these services, like, and I'll just scroll through them, I don't got to read them to you. These are the types of metrics that are exposed by CloudWatch. And then what we've done is basically built a predefined dashboard, just plopping on all and formatting it so it looks nice, all those available metrics that are exposed by CloudWatch. So in addition to that kind of CloudWatch visualizer thing I just showed you, there's these dashboards that can view all this data. And let me just, I don't know where I can paste this, but maybe I'm not sure where my window is, but maybe one of you guys that are supporting me here just, so dynatrace.com snippets, and then there's dashboarding. So this just shows you the kind of data that we can visualize and bring in, and then all of the same data can be queried from the API. There's like custom queries, custom dashboards that you can build all from that data. But then the more important thing is it comes into the AI engine. But to kind of show you this, the one limitation is for Lambda. So the way we've supported Lambda in the past is one, if it's maybe my environment doesn't have any Lambda functions. That's probably why. But if you had Lambda, we would just see what CloudWatch exposed, and then you were required, and we only supported one language, and you had to put an SDK in your code and compile it. I think it was the Node.js is what we supported. But now, I think it's in the October timeframe, is AWS created the new framework for Lambda, where now we can inject an agent at runtime and have it cached as part of the Lambda framework. And so now, this has been a limitation around Lambda, but now we'll have multiple language supports and then have it all dynamic and then really support a lot of great stuff around serverless. So this particular serverless aspect, I think, has been a little bit of a gap, but now with AWS, support, we're now closing that gap. And I think it's everyone else too. Everyone else had the same limitation too. So it wasn't just us Dynatrace. It was anyone that wanted to stick an agent, or to could just be security vendors too. Didn't have to be an observability vendor. But now that's something that's cool that's coming. I think. Let's see what else. Hopefully that answered that question.
Yeah, that's super great.
Oh, another thing that's coming for us too is more DevOps support. I think that's one thing. Our data model, and I might have to show you it. My demo environment does have a really interesting web UI, but what we just see if I can. I don't know if I want to flip over to that, but what the end user experience of the app, let me just take a shot. Maybe I can get lucky here with my app. So what Dynatrace in addition is doing, and this is maybe just a feature I'll show, is in the front end app itself, we are automatically, you can control it, but it's also automatic by default. So because we are attaching into your web server process, while the content is being rendered back to the browser, we inject in this little chunk of JavaScript, which then becomes a JavaScript agent running in your browser. And so by having this piece of code in there, it's also sending data back to Dynatrace that's how it does the end user experience. So when we look at sessions, and I come into some of my sessions here, let's see, maybe I can get lucky. Find something interesting. What I can see is now every single session that came in from end users of what's going on in the app. So in this case, I drilled into a user session, and since I'm in a constant loop, I have multiple sessions for myself, which is anonymous. But you can see here now I can get information. I'm on a Mac. This is where I live. I'm running this version of Chrome, and then you can see I'm just continually running over and over and over again the front end page load, which is nothing too interesting. But if I had a user session where I was navigating, just imagine I was navigating around an app, I place items on my shopping cart, I check out, whatever. I now see everything they did, and I can see a timeline. This is not because it's just a loop. It's nothing too interesting, but you could see, where they were taking time, where they got frustrated on pages. And then what's really cool is now I can see this waterfall analysis. So if you've ever seen a front end development tool, what's happening is, okay, it's interesting how it rendered this. But what's happening is all your static resources are being seen. You can see the time taken, all of my pages that were done here. This is just not a good example. Let me just, if you bear with me 1 second, I think I'm always blown away by this demo.live.
You say it was not a good example, but it's still enough to explain my brain. So.
Yeah, well, you get the concept. I think when you see like a real web page, and I just take 2 seconds if you don't mind, I'll just show you just a little more interesting example of a user session. We just pick one from our demo, another environment. So here we can see, this is Maria coming in doing real things. So let's just pick on this one random. And so this is, Maria was in her session for 1.5 minutes. She came in from here. And see, now that's what I meant by, like, you can see where she was taking time, where were, client-side user actions. And if we were to look at this load of this page, she was frustrated for some reason. Let's do the waterfall analysis on it. And so that's what I meant by it was more interesting. So now this is more like real world app where the style sheets, there's static resources, dynamic resources. You can see maybe third-party requests. So you can really see where time is taken at a very granular. So you can roll all this up to like, what's the health of my app, but you can now like drill into a really frustrated user and see this specific page on a specific session that she was doing. And then the beauty of it is if it made a server-side call, which is like in this case, I can now drill into the pure path of what was that call doing. So if I was to go into the code, I just pick one that probably just calls one thing. But anyway, you can drill in from the front end to the back end and see, make that's where Dynatrace automatically connects what was happening from the front end calls to the back end calls and links them all together, as a single distributed trace from that specific user to the back end calls. And that's what's kind of cool about it.
Just really like troubleshooting nirvana. You can trace an issue all the way back, up and down, either way.
Super cool.
Exactly right. Yeah, super cool. And just to show you, see if we can get one last little time for demo here. If you remember in our environment here, let me go to my EC2 instance, which is this last guy. If you notice in this app here, this is another EC2 instance, but it doesn't have a Dynatrace agent on it. So if you want to see what's a Dynatrace agent, so this terminal shell that I was in, this is that same machine. So this machine is, nothing's running on it, it's just that machine. So the way we deploy Dynatrace is I can say deploy Dynatrace. And so Dynatrace is at the host level. So in this case, this is an EC2 instance, not Kubernetes. So just to show you how easy it is on a host. So it's at the host level. So there's different installers. And again, all these installers can be wrapped in a configuration management tool. We have a new partnership with AWS where we can deploy the one agent as part of the system manager distributor model. So we are now certified to have the agent run through system manager. If you know that, maybe we can share that blog article too to explain how that works. But all we're going to do is, so built into your tenant you have a specific downloader and it gets configured. I'll just run it while I'm talking. So it's on this host, I'm going to get the agent and it's getting it from my particular cluster and has the information it needs to connect into my machine. And now the agent was downloaded. And then now to install it, I just do the sudo in this case. So now I'm just going to say, hey, go ahead and run the one agent. And it runs pretty quick. Da-da-da-da. And so this is where people run it. So there's lots of ways to roll this agent out. Like we've done it with user data, in CloudFormation scripts. System Manager is a way to get out. If you use Chef or Puppet, Puppet, you can use it. You can do it that way if you have your homegrown scripts, because it's really just two commands all you're running. So you've downloaded it and installed it. So what System Manager is doing is sort of automating this for a fleet. So if you had the System Manager agent running on a fleet of EC2 instances, a couple hundred, you could say, roll out my agent, upgrade my agent, whatever, and let System Manager do it for you, and they get all the auditing for you. But now, by that being done, let's just go see our hosts. And, now it's starting to be recognized here already automatically. So here's my simple host that we showed earlier. And now we can see I got more information, and now it's starting to pick up the processes running on the box. If I could pick on processes, it might take a second more to get the data, but now it's starting to automatically pick up the information on this host. And I'll kind of go quick because we want to show this thing. So if I show, now let's go ahead for the same simple app. I have another way I can deploy it. Where am I? Scripts, deploy. And I'll just, if you're new, since we're learning a lot of new things here, you can run Docker just with a Docker, Docker run command. So I have basically a script that may look fancier than it is, but at the end of the day, it's running a Docker run command, giving, and I'm passing in these environment variables, and then what's the image I want to run. And that's just part of this method. And so down here, I'm just calling it like start the container. I want to start this image, number one, run it on port, whatever, and then give it these names. So you can see I'm basically running that same demo app now through Docker on this instance. And so now it's attempting to download the image, which I already have downloaded. So they look like error messages, but they're just saying you already have the image. And now it's running all the Docker commands. And what that output was just sudo docker ps. So now this is all the Docker processes that are now running on this EC2 instance. So if I go back over here, hopefully it picked them up. It might take a second here sometimes it might take a minute to show up, but what will happen here is, give it a second. Come on. Yeah, once in a second. So all these processes will now be picked up by the one agent, and we should see them. And then while that's doing it, I know what I have to do. So while it's I have to actually go to that front end, because Dynatrace needs traffic to the app to see things. So if I go to the IP address of that app, if you notice now I'm on EC2 instance 1 and I'm on port 8090 is the other guy. So now I have two instances of the app. Let me just go ahead and really jack up the speed that it's going to hit this app. And then I'll show you one last cool thing when we're done this. So I've got app one. So app one and app two are collecting. Let's go back to Dynatrace. Close these two tabs open here. Okay, there you go. See, it picked up all those processes automatically that are running on the machine. Okay. And so now if I go to my transactions and services view, they will eventually show up here. So you can see my Boom app is there, and it might just take a minute for it to register as a service on this view. Okay, they're there. So now, boom, they just showed up. So now I have the EC2 version of this app and now the Kubernetes version of this app all running at the same time. Let me just go ahead and turn this error off on the Kubernetes one because I'm kind of sick of looking at that. So let's turn it back to healthy. Okay. And now my web app. So the Kubernetes one is happy, right? So he's happy because I turned the error rate to 0. And then this guy is still chugging along. So hopefully you're following all this. I know I'm going kind of fast. But now you can see the apps are here. If I come into the web app, and now I can so again, looks just like the other one, so that's a nice thing. So whether it was a EC2 instance process or a Kubernetes process, the way Dynatrace, once it treats it as a service, it's going to look the same. And if I look at the service flow here, now you can see EC2 Web App 1 calls number goes down down the chain. These are kind of here just the way, this is sort of a residue of the startup, but this will go away. But then the last kind of cool demo is let's do this for fun. Let's now take Web Service 5 of my Kubernetes app and let's configure it to, and again, because that's to be query string, I'm going to point it to the endpoint of the EC2 instance flavor. So let me just copy this for demo purposes, just to save myself the trouble. So now Web Service 5 on Kubernetes is calling Web Service 1 on EC2. So if you look here, there you go, that's what I wanted. So now my chain of, oh, did it do it? Oh yeah, I did. Okay, I guess I called number 3. I'm sorry, I guess I skipped it. So I actually, so Service 1, oh, that's interesting. I guess I kind of broke my chain, but here, Service 1 is calling Service 1, Service 1 is calling 2, 2 is to the, oh, you know what I did? I'm sorry. Yeah, hang on, I messed up. I changed the wrong service. My apologies here. I broke my own thing. So I changed the top level one to the other one. So what I want is, this is the problem with the DNS. Let me do 2 seconds here. So KD get. Yeah, so this is because I have this, I just kind of screwed up. Do this. I want this one. I want number 5. To point to that. And then I need number 1 to point to number 2. So let me just, I'll fix it. Sorry, just bear with me 1 second. So
debugging is wonderful.
All right, so what I'm doing now is making service 1. If I go back, number 1 point to number 2. So hopefully I fixed that. Let's see. So did I get it right? Okay. So hopefully this is right. So now I have, here, let me pause it because it's hard to read. So what I just did is kind of on the fly. I have service 1, so that I prefaced it with K8. So K8's calling 1, 2, 3, 4, 5, right? And then number 5 is calling the endpoint of EC2. So he calls, so then EC2, 1, 2, 3, 4, 5 calls. So now I have like a chain of 10 service calls happening here, which is kind of interesting and dynamic. So this could be, something happens in your environment, things change. And just for fun, let's see if just for Dynatrace picks it up, but let's change, just another thing we can do is down here on service 4, this guy, save it. What I can do is, here, I could do it manually. Sorry, it's all these refreshes are killing me here. Stop. All right, so if
Rob,
I change.
we have 2 minutes left on our stream. Yep. So we have provided our viewers with so much information about Dynatrace and Kubernetes and all of that. What additional resources can we provide to them so that they could best learn about Dynatrace?
Sure. Absolutely. Yep. And I will finish that thought. So what I did is I added a delay on one of these lower level services. And so what's going to happen, I'll just show you this thing, and I'll switch right to your question. So that's a great question. So what happened here, let's see if it did it dynamically. If I go now to web app number 1 in Dynatrace, go to the service flow, and I should now see this chain of command taking place. One calls two, and again, now it made the hop from service 5 to EC2 service 1, service 1, 2, 3, 4, 5. So now you can see how that's the dynamic, real super duper dynamic example I wanted to show you. But going to resources, one thing that we have as a great resource is in kind of work with AWS on a real hands-on workshop. So this URL is part of a modernization series that AWS created, and so this tutorial will walk you through how to get an AWS account, get a Dynatrace trial, which is a full-fledged cluster on SaaS for 15 days. And then you can follow the guide where it'll run CloudFormation scripts to set up some hosts and walk you through everything I kind of showed you today, so you can learn kind of all the features. In addition, it has a section for setting up the AWS monitor. And then once you have your cluster, you're not limited to just using that demo. You can do what I did, just take it and install one of the agents on some of your infrastructure and see what it does. Obviously, our public website is a great resource, and then all this code. Here's the link to the code itself, and then you guys will probably see me anyway. But this is who I am. You're welcome to reach out to me. In fact, if you sign up, you'll my information I think was on the Twitch thing, so you can reach me on LinkedIn. You can reach me here. You can reach me through these guys. Not a problem. So hopefully what you learned today, I know there's a lot, is that this is one just bullet point, which is easier to kind of see that this is kind of what we want you, is like the cloud, AWS, is part of the transformation, dynamic infrastructure, the ability to support, containerization, microservices, and all of this stuff is going to be dynamic. And so we need to have tools that support it, whether it's your configuration management tools, whether it's your security solution, or an advanced observability tool like Dynatrace that can then also support not just everything on the cloud, but also things that are still on-prem or things that you will maybe keep in a hybrid mode just because, and also AWS Outposts is also another thing that we support too. So we're fully certified with Outposts. So that's where a lot of people are kind of bridging that gap. So if they don't want to go full cloud, keep the investment in the data center, they could plop an Outposts, rack or racks on-prem, and then have all the features of kind of a seamless management that way. But then we really want to drive towards, a combination of culture, tooling, DevOps, automation, to really shrink down the mean time to innovation, we like to call it. So how quickly can you deliver new pieces of code, but do it in smaller pieces so that you're not putting at risk every little break, and then having that ability that we talked about earlier around either a canary release or a blue-green deployment to kind of minimize that risk as you're making change. And it's at the end of the day, and that's where the big Dynatrace message is about. Like it's not just an application monitoring tool. It's an end user experience tool too. So we want to know what what's happening with the end user, because that's what's going to drive the priorities. If the users are impacted, we got to get on it and get to the root cause quickly. But if they aren't impacted and it's just a high CPU on some random box, we can prioritize that as a lower level problem.
Totally agree. Successful customer outcomes is what we're here for. Thank you so much, Rob, for joining us in today's episode. That was so great. Our viewers are
putting out
shout outs about how much they love the interface and how much they like the tool. So thank you.
Yeah. Thanks for the opportunity. Yeah. Hopefully we'll do it again.
Gregor, thanks for co-hosting. And I want to give a shout out to A.M. Grabellini, who is our master operator behind the scenes and also our executive producer. Howdy Partner airs every Monday and Wednesday from 2 p.m. Pacific to 4 p.m. We'll see you guys next week. Thank you so much for joining us.
Thank you. All right. Have a good day.